dear students, for Standard 8, Subject Science, Chapter 4, Current, Electricity and Magnetism, Module 3. Before beginning with the lesson, let us understand what are learning objectives. In this lesson, you will learn about electric cell, magnetic effect of electric current. You will also learn about applications of electromagnet and electric bell. Let us begin with our lesson. Now take a cell and connect it with the other cell. This is called a battery. Batteries are a collection of one or more cells. Let us understand this in more detail. A battery is a combination of two or more cells connected in series combination or parallel combination. So students, do you know what are these combinations? Well, if the cells are connected as with their opposite terminals together, then we say that this is a series combination of cells. We simply say that the cells are connected in series. Let us study about parallel combination. Parallel combination is when the positive terminals or the negative terminals of the cells are connected together. The example for series combination is an electric torch, whereas the example for parallel combination is an electric board. In today's science class, we will study about series combination of electric cell. Now let us study about cell holder. Look at this image. This is a cell holder. Cell holder has compartments. This compartment helps to keep cells safely. Look carefully. You will observe that each compartment has a spring, and when we place the cell in this cell holder, we compress the spring by negative terminal of a cell, and this spring is made up of metal and it conducts electricity. On the opposite side, the positive terminal of the cell is also in contact with some metal. In the same way, we will insert the second cell. But are the cells connected in series combination? Yes, although it looks like parallel combination, but they are in series combination. If we carefully look at one end inside an empty cell holder, we will find a thin metal wire connecting the positive terminal of one side with the negative terminal of the other side. So that's how the cells inside the cell holder are connected in a series combination. Now let us study why we use connecting cells in series combination. Let us study about connecting cells. Students, you must have seen more than one electric cells connected in an electrical circuit. In the transistor, radio, 2-3 dry cells are seen to be connected in the series. The purpose of doing this is to obtain more potential difference than that of a single cell. Therefore, it is possible to obtain higher current if the cells are connected as shown in figure. The connection of cells is known as a battery. In this series connection, the positive terminal of one cell is connected to the negative terminal of second cell, and the positive terminal of the second cell is connected to the negative terminal of the third one. Therefore, each cell has a potential difference of 1 volt. The total potential difference of 3 cells will be 3 volt. Let us understand this with the help of an example. Let us understand this problem. Three electric cells of potential difference 1.5 volt each have been connected as a battery. The potential difference of the battery will be, let's find it out. When electrical cells are connected in series as in a battery, the potential difference of the battery is the sum total of the potential difference of each cell. Therefore, the potential difference of the battery is the sum total of their potential differences. That is, we need to add this value, which will give us the final answer as 4.5 volts. Simply, we can say that when cells are in series combination, the voltage adds up. Now let us study about magnetic effects of electric current in detail. Magnetic effects of electric current. Let us understand this concept with the help of an activity. Take the inside tray of an used up match box. Place a small magnetic needle inside the tray. Now take a long connecting wire and wind it around the tray. Complete the electric circuit by connecting in it the wire, electric cell, plug key and a bulb. Mark the position of the magnetic needle. Take a bar magnet near to the magnetic needle. What do you observe? Keep looking at the needle and close the plug key. The bulb will light up and you will realize that the current has started flowing. Does the magnetic needle changes its position? Now open the plug key. Does the magnetic needle come back to the original position? What will you conclude from this experiment? Students, you will observe that when the switch is off, no current flows in the wire and the compass points in the north-south direction. But when the switch is on, current flows in the wire and the current gets deflected from its usual north-south direction. We know that a magnetic needle is indeed a magnet. We have seen that the magnetic needle changes its direction when a bar magnet is taken near the magnetic needle. Also, we have observed that the magnetic needle changes its direction when a current starts flowing in the circuit. This means that magnetic field is created when an electric current flows in a wire. Briefly, we can say that when an electric current passes through a wire, a magnetic field is produced around that wire. This was the conclusion of this experiment. And students, do you know who made this conclusion? Hans Christian Ørsted was one of the leading scientists of the 19th century. He played a crucial role in understanding electromagnetism, and this experiment of a wire and a magnetic compass was performed by Ørsted during 1820. Now let us understand this activity. The required materials are a copper wire, battery and iron screw. Take a meter long flexible copper wire having resistive coating and wind tightly on a long iron screw. Connect the two ends of the wire in a circuit as shown in the figure. Also connect an electric cell and a plug key in the circuit. Keep two forked iron pins or small nails near the screw. Now start the current in the circuit by plugging the key. It will be noticed that the pin's nails have stuck to the tip of the screw. Will the pins or nails continue to stick when the plug key is open? When the electric current flows in the wire, magnetism is produced in the coil around the screw, and because of that, the screw also attains magnetism. As soon as the current is stopped, this magnetism vanishes. The system of coil and the screw is called an electromagnet. Electromagnets are used to produce strong magnetic field useful in scientific research. Now we will learn about the applications of the electromagnet. Now let us understand the use of electromagnet. Large machines are used to lift up cars. This machine has electromagnet, and this electromagnet are so strong that they can lift up a car. Electromagnets are also used to separate metal objects from pile of junk. This is another application of electromagnet. MRI machine works on the principle of electromagnet. Let us see another useful and important application of electromagnet, that is Shanghai maglev. It is a world fastest train which works on the principle of electromagnet. Students, have you observed this kind of objects? Think about it. This is an electric bell. Since students, now we are clear about the term electromagnet, let's understand the use of electromagnet in simple devices such as electric bell. This is the internal structure of an electric bell. Let us understand the names of the basic components. This is a key. Here is an electromagnet. This is a battery. This is a striker. Here is a bell. This is a contact screw. Above it, iron strip is placed, and this forms an electric circuit. This was the internal structure of an electric bell. Let's understand the working of the bell. A copper wire is wound around an iron piece. This coil acts as an electromagnet. An iron strip along with a striker is fitted near to the electromagnet. A contact screw is in touch with the strip. The electric circuit is connected as shown in figure. The current flows in the circuit when screw is in contact with the strip, and hence the coil becomes a magnet and attracts the iron strip towards it. Therefore, the striker hits the gong and the sound is created. However, at the same time, the contact screw loses the contact with the strip and the current in the circuit stops. In this situation, the electromagnet loses its magnetism, and the iron strip moves back and comes in contact with the contact screw. The electric current is then immediately restored, and again the striker hits the gong by the above process. This action repeats itself and the bell rings. Let us quickly summarize what we have learned. We have learned about series combination. We have also learned about that when cells are connected in series, voltages add up. We have learned about magnetic effects of electric current, applications of electromagnet, and electric bell. Students, you all are supposed to solve the answer for these questions. Students, note down this answer. This will help you to understand the concept of electric bell in detail. Here is an interesting assignment coming for you all. Find out the devices in which electromagnets are used. Thank you, my dear students. We will meet in the next video.